Imagine a world where robots look and act so much like humans that you can't tell the difference. It's a vision of the future that both excites and terrifies us. One that science fiction has explored for years. But how close are we to making that vision a reality? Think of the movie Ex Machina. We're introduced to Ava, a humanoid AI that captivates not just with her intelligence, but with her humanity. Throughout the film, we see a machine capable of thought, emotion, and self-awareness. Ava raises questions about what it truly means to be human, and whether machines could ever reach that level. But Ava's world isn't just a fantasy. Today, robotics and AI are advancing rapidly. From humanoid robots that walk and talk to AI systems that can hold conversations with us, the line between fiction and reality is becoming blurrier by the day. In this video, we're diving into the world of humanoid robots. What's real, what's possible, and what still lies ahead. The future of robotics is no longer just a dream. It's a reality being built by some of the world's most innovative companies. Leading the charge in humanoid robotics are giants like Boston Dynamics, Honda, and Tesla, each working to create robots that move, think, and even interact with us in ways we once thought impossible. Take Boston Dynamics, for example, with their groundbreaking humanoid robot, Atlas. Atlas isn't just a robot that walks. It can run, jump, and even perform backflips with precision that rivals a human gymnast. This level of mobility and agility represents years of advances in mechanical engineering, control systems, and sensor technology, allowing Atlas to balance and move fluidly in the physical world. Then there's Honda's Asimo, one of the pioneers in humanoid robotics. Asimo's design focuses on interacting with humans. It can recognize faces, respond to voice commands, and even serve coffee. This human-robot interaction is powered by advanced natural language processing and AI, enabling Asimo to understand and respond to people in a way that feels surprisingly natural. Now, enter Tesla with their latest project, Optimus. While it's still in the development phase, Tesla envisions Optimus as a robot that could one day perform repetitive tasks, assist in factories, and even help in homes. Tesla's expertise in AI, particularly in self-driving technology, plays a key role in Optimus's development, allowing it to navigate environments and make decisions based on real-time data. At the heart of these innovations are key technologies: artificial intelligence that powers decision-making, robotics that provide movement, and sensors that allow robots to perceive the world around them. Together with advancements in mechanical engineering, these technologies are enabling robots to not only function but thrive in human environments. While we're still in the early stages, these companies are laying the groundwork for a future where humanoid robots could become a common part of our lives, helping us at home, at work, and beyond. As we've seen, companies like Boston Dynamics, Honda, and Tesla are pushing the boundaries of what humanoid robots can do. But what exactly goes into making these robots capable of such incredible feats? Let's take a step back and look at the process behind the creation of these mechanical marvels. From their initial design to the final product. From the drawing board to reality, creating a robot is a complex journey that involves engineering, AI, and human ingenuity. Let's take a quick look at how humanoid robots, like those we see in cutting-edge labs, come to life. It all starts with the design phase. Before a robot ever moves, its structure is meticulously planned. Engineers and designers work together to sketch out the robot's physical form. They ask key questions. How tall should it be? How many limbs does it need? Will it walk, roll, or fly? Using computer-aided design CAD software, they create 3D models to map out every component, from joints and sensors to the outer shell. Once the design is set, the next step is mechanical engineering. This is where the robot's body comes together. Engineers choose materials that are strong but lightweight, like carbon fiber or aluminum. They then build the robot's skeleton, assembling motors, actuators, and joints that will allow the robot to move. For humanoid robots, this means mimicking human motion, so they install sophisticated joint systems that enable the robot to walk, lift, or even dance. But movement alone isn't enough. A robot needs to be able to interact with the world. This is where sensors come in. Robots are equipped with sensors that act like their eyes, ears, and skin. Cameras and LiDAR systems help robots see their surroundings, while force sensors let them feel how much pressure they're applying when, say, picking up an object. These sensors feed data back into the robot's system, allowing it to react and adapt in real time. Next, the robot needs a brain. This is where artificial intelligence, AI, plays a crucial role. AI is the software that powers the robot's decision-making abilities. Engineers program the robot's onboard computers to process the data from its sensors and make split-second decisions. For example, if a robot is walking and detects an obstacle, the AI helps it decide to step around it. Natural language processing, NLP, can be added, allowing the robot to understand and respond to human speech. AI is what gives robots the ability to learn, adapt, and interact with humans in increasingly sophisticated ways. With AI in place, the final step is integration and testing. This is where all the robot's parts, the body, sensors, and AI, are brought together. Engineers run countless tests, making sure everything works as it should. The robot is programmed with tasks and then set loose in a controlled environment. Engineers observe how it performs, tweaking the design or AI algorithms as needed to improve its accuracy, speed, or responsiveness. Sometimes this testing phase can take months or even years as developers refine the robot's performance. Once testing is complete, the robot is ready for deployment. Depending on its purpose, it might be sent to a factory floor to assist in manufacturing, work in a hospital alongside doctors, or even be used in research labs to assist scientists. Humanoid robots are also being developed to perform tasks like assisting the elderly or providing customer service. And soon, they could be working alongside us in everyday life. So, to summarize, robots are made through a process that involves designing their physical structure, building the mechanical parts that allow them to move, installing sensors that let them perceive their surroundings, programming them with AI to make decisions, and testing everything to make sure it works seamlessly. While it might sound simple, the reality is a complex dance between software, hardware, and human creativity. And as technology evolves, we're likely to see robots become even more sophisticated, intelligent, and lifelike. While the progress in humanoid robotics is undeniably impressive, the road ahead is filled with significant challenges, both physical and technological. Let's explore the key hurdles that stand in the way of creating robots that truly mimic human abilities. First, there are physical limitations. Human motion is incredibly complex. Our bodies can perform a vast range of movements, whether it's the precision of picking up a pen, the endurance to walk for hours, or the agility needed to sprint or change directions in a split second. Creating a robot that can match this versatility is no small task. Mechanical engineering, even at its current level, struggles to fully replicate the flexibility, dexterity, and fine motor skills that humans take for granted. While robots like Boston Dynamics' Atlas can perform backflips and other stunts, achieving this level of fluidity and control across all types of movement remains an immense challenge. Then there's the issue of artificial intelligence. While AI has made tremendous leaps in recent years, allowing robots to process information, learn from their environment, and even hold basic conversations, there are still major gaps when it comes to replicating human understanding. AI lacks consciousness, emotions, and true decision-making capabilities. Even the most advanced robots can follow pre-programmed instructions, but they don't think or feel in the way humans do. They struggle with complex, real-world decision-making, especially in unpredictable or highly nuanced situations. This brings up ethical concerns too. Should robots be given autonomy to make critical decisions? And if so, who bears the responsibility for those choices? These questions are far from being fully answered. Another key challenge is power and energy efficiency. Humanoid robots, especially those designed to move and interact with their environment, consume massive amounts of energy. Finding a power source that allows robots to operate independently for long periods without needing constant recharging is a huge hurdle. Most robots today are still tethered to power sources, or they can only function for short bursts of time before needing to recharge. Until we can create highly efficient portable energy systems, robots will be limited in terms of both functionality and mobility. Cost and scalability also represent significant barriers. Humanoid robots are incredibly expensive to build and maintain. The research and development alone requires millions, if not billions of dollars, and that's just to produce a single working prototype. Scaling this up for mass production, especially if these robots are to be adopted in everyday environments like homes or businesses, adds even more complexity and cost. For now, humanoid robots are a luxury that only large corporations or research institutions can afford, making widespread adoption a distant reality. Finally, there are safety and security concerns. Giving robots greater autonomy raises serious questions about how much control they should have and what happens if things go wrong. What if a robot malfunctions or is hacked? Could it pose a danger to humans? These concerns are not far-fetched, as even simple software glitches can lead to unexpected behaviors. Moreover, privacy is another issue. Robots equipped with cameras and sensors could inadvertently capture sensitive data, leading to potential misuse or security breaches. Balancing autonomy with safety remains one of the most critical challenges that developers face. In summary, while humanoid robots have come a long way, the road to creating machines that truly mimic human abilities is filled with significant hurdles. From physical limitations and energy challenges to ethical concerns and security risks, it's clear that while robots may one day walk among us, there's still a long journey ahead before they become a seamless part of our world. In our next episode, we'll be exploring the exciting world of flying cars. Could they be the solution to traffic congestion and the next step in personal transportation? Companies are already developing prototypes, and the technology might be closer than you think. We'll dive into the current developments, the challenges of airborne mobility, and whether flying cars could soon be more than just science fiction. Stay tuned to find out.